Good morning and welcome back to Hannover in the mid-north part of Germany, one could say. It's Wednesday, 19th of April, and we are very, very happy because our booth is already crowded. The trade show started an hour ago. A group of Danes from the country of cycling and windmills is standing behind us talking about I/Os. Yesterday was a super special day. First time in a couple of years we had a booth party.
Right.
It was very, very crowded. Amazing music. Students from Hanover, politicians and people from the industry were at our booth. It was a very, very nice party. And something what also happened yesterday, what was pretty special to me, was that our Vice Chancellor and our Minister for Economy and Climate, Mr. Robert Habeck, visited our booth, and he had a very long discussion with our Managing Director Hans Beckhoff and with his daughter Friederike Beckhoff about, for example, machine learning, IPCs, and that was the best for me, X-Planar.
Yeah.
So prepare for the next half an hour of technology, and if you want to go back and watch how Mr. Robert Habeck visited us, you can do this on our website. But then I think now we have to start, right?
Yeah, but Mr. Habeck had the chance actually to get directly in touch with us. Now you're obviously at home listening. If you would like to get in touch, use the chat functionality you can see on your window or send us an email. This is meet at Beckhoff. And then we have a group of experts behind us, basically back office, and they can answer your question right away. Or we even pick your question for a live answer.
Yeah.
Okay, let's go. I will go into our terminal corner, because when we talk with Beckhoff and our technology, we always talk about EtherCAT. You remember yesterday, the day before, we talked about EtherCAT, the communication backbone, about performance and so on. And now I am in the field of our terminals, but I don't want to talk about EtherCAT. I would like to discuss with Sebastian the news and the features of Ethernet-APL. So let's get some light into the dark. What is Ethernet-APL?
So Ethernet-APL is a new communication technology for the process industry. It's based on two standards. On the one hand, we have the Ethernet, the IEEE Ethernet standard, which is designed for the communication speed of 10 Mbits per second. We have a maximum cable length of 1 kilometer, and we do that all over just a single pair of cable.
Okay.
On the other hand, we have the explosion protection, which is an ISC norm. Mm-hmm. And this is designed for the intrinsically safe environment, and use that over the same pair of cable to get the energy to the field devices.
Okay, so that's the technology in the field for basically explosion-proof applications, mainly maybe process industry. We have a wide range of products for that since a couple of years, so this is also our core expertise. But why have we chosen now Ethernet-APL as an addition to this portfolio?
Ethernet-APL has a few benefits for the process industry. The one keyword is digitalization. Mm-hmm. So we want to get more information out of our plant. For example, via a web server, we want to have just more information about the process. We want to do predictive maintenance, and all of that means we need more data. We need a higher communication speed, which the current technologies like HART, like Foundation Fieldbus or Profibus PA just don't provide.
Okay.
Yeah. So that's the idea behind Ethernet-APL, why we need that.
Okay. Now, usually we put all these new technologies in the same form factor, and I see already, Sebastian, you have a terminal in your hand. It's a 24mm wide one. So that's all it needs to get access to Ethernet-APL, just one terminal?
Exactly. So that's our idea behind that. We do not need a big switch or something. We have it all in our small terminal in our ELX series. And we have on 2 ports on these 24 millimeters. It can be directly connected to all the other ELX terminals and all the other EtherCAT terminals. So we can, directly connect to other communication technologies.
So it's perfectly in line with all the digital inputs and outputs and analog signals we have. You just put it in between. Now, maybe finally, what is the reason for this approach? So why have we chosen that?
The idea is that the customer wants to use the existing technologies like HART, like Foundation Fieldbus, or just like single 4 to 20 milliamps of signals. And we want to provide a solution to combine that with a new technology like Ethernet-APL. So that's the idea. That's why we've chosen this solution and to integrate it into our existing system, of course.
Perfect. Thank you so much. Now, for you as a customer, the success story continues. We take the existing portfolio of our explosion-proof products, ELX, and just by adding one other terminal, you get the next feature to it. I hope this brought some light into the dark. That's a good point over for Felix, because he's in the vision department.
Yes, I am. But before I would like to go into the vision technology, I would like to put your focus on something which we barely touch upon. We always talk about technology, we always talk about the advantages which we see in the technology, we maybe talk with our customers, but we rarely talk about design. So everything which you see on the Beckhoff booth follows a clear form follows function principle. And you know that our IPCs, our motors, everything what we have has also a design component, because it should look like, it should feel, it should look nice, and it should feel nice as well. And one product which already won a design award is our new vision technology. So for example, the Red Dot Design Award. But Bernd, you're having the camera in your hand, and to be honest, it looks fairly big. Did we maybe sacrifice functionality in terms of form?
No, I think our customers really like this robust housing, what is directly mountable in the machine with the integrated covering of the lens and the IP protection. And the camera is not big. Here, look, it is extremely short, and also the cable is going out by side, so we need no additional space behind the camera. And these dimensions, optical axis, often is constrained in the machinery. Okay. And the other cameras are longer, and you have to add the cable bending radius. So here we are really short.
Okay, so we actually save space because we are going out of the edge. Thank you for clarifying this, so I can tell our customers now. Another product line which we have here is our optics, and I see that we have two different kinds of optics here on the wall. What can you tell me about that?
Yes, we have a wide range of sensors from 1.6 megapixel to 24 megapixel, and also the size of these sensors is different. And so we need a smaller, cheaper lens for the smaller sensors, and we have here the edge of 11 millimeter image circle. It is well known in the market for the smaller sensors, and we have one lens for the bigger sensors. And clear, we have not only a robust housing here, we added also a really high quality optics inside. And for the bigger one, we decided also to have a better correction of the color, and so we have the same focus point for visible light and the near infrared.
So different sensors require different optics, and I think that it's very much in line with our philosophy of continuity. Yesterday I talked with Heiko about the CX92 and the CX82 platforms, which are sitting in between some smaller end or some lower end controllers, and also here we always have the right component for the application.
Right component for the right application.
Another component, the third component, which you require when you talk about vision is light. And I'm very happy that you turned it off today, because our lighting is actually very bright. It's flashing really, really hard, and it's flashing also very fast. And why do we need so many colors, so much light intensity?
So the change of the color is often very important to have the optimal contrast of your product for the feature what you want to check. And if you change the color of your material or the material itself, you need another color to have the optimal contrast. And it's very easy. You can reach the color by parameter in the PLC. Okay. It's easy to change. And the high power for flashing is extremely important for us, because we have very fast transportation systems and we want to freeze the movement. We don't want to stop and start again the product. It needs place and time, and also energy. And so we need an extremely high power. But don't be afraid. This flash normally in the field is extremely short, so that the human is not really disturbed. Here we make it a little bit longer, that you can see something, so otherwise you would say, oh, it's a switch off.
Okay, now I understand. So we need to flash hard in order to move fast. Thank you very much, Bernd. And now let's look at the software side of the vision, because hardware is one thing, but you know that there is always an integrated software functionality in the Beckhoff portfolio when we talk about hardware. We have some fruits here, so we're not having breakfast right now. But I think we would like to answer a philosophical question. So, can you actually compare apples and bananas?
Yes, but the main reason that we have these fruits here is that these natural grown fruits are a perfect example to explain and what benefits you get with our new machine learning functions, because everybody knows it, everybody can detect it, because we trained it, we learned it over the years, but now we have the possibility to use the training for the machine learning functions in comparison to use classical approaches. Maybe we can detect the object with classical approaches, but analyzing all the features would be a hard task.
I think for me now, this banana looks a little bit, it already had a rough start into the day, I would tell.
Yeah.
And what I think is pretty hard to tell if you use a classical algorithm is the degree of aging of the banana. Is this something where machine learning can help us a little bit?
Yes, for this we can train a regression model. And if we train all the aging steps, we can make a progression. What is the age of the banana? And we can also use an anomaly detection model to look for all these defects, because they can look always different. And this is the problem with the classical ones, where you have to use so many parameters. You might solve it, then something new appears and you start all over again.
Yeah, so of course with the machine learning you need to get the data, you need to label the data, you need to train the model, but once you have done it you can easily deploy this to all kinds of different use cases. And I think that's a very powerful approach. We are using it in the Explanar for the position detection, and again it shows whenever you have a task which you can't describe in an algorithm, you can do it with machine learning, or you can most of the time do it with machine learning. Okay, last but not least, how can we bring this amazing feature, this amazing learning capability to the machine, especially in the vision?
Yeah, we simply provide it with our existing vision library. So we add the functions to train the model and then run the inference both in real time. This product starts with the classical models like an SVM, K-means, PCA and so on. And at the end of the year we will also have the possibility to run deep learning models which provide better quality or more features that you can extract automatically from the model.
Okay, I'm pretty excited how much we can teach the machine with machine learning, and especially in the vision area. Thank you very much, Michael. We will now switch over to the next TwinCAT functionality, which is about auto-tuning, and this has nothing to do with your car. Haha.
Well, I think this needs to be explained. Tuning is simple, but auto is the German word for car. So when we talk about auto tuning in Germany, people believe it's car tuning. And I have to admit that my 17-year-old son, who is just making his driving license, he was all about it. He said, "So cool, Roland, you do tuning of automobiles, so of cars in Germany." Well, we don't do that. We auto-tune motion products. And in order to explain this, I got two experts with me, Daniel and Pascal. So we talk about auto-tuning. So let's say, when and what is this all about?
The auto-tuning is an automatic function to optimize servo drives.
Nothing with cars, right?
No.
Okay.
It has nothing to do with automotive, nothing with cars. We only tune servo axes and try to optimize them. This is necessary, or each customer has the need to optimize the axis. He wants to avoid vibration, resonances, and instability of the axis, because if that's possible, the product quality is better, the quantity can be also higher, and we can increase the lifetime of the mechanical parts, because we do not have overshooting and stuff like that. So there are a lot of benefits of tuning axis.
But I think that requires a lot of expertise. I think there is the senior engineer with 150 years of experience who then manipulate all the little push buttons and tune it. But now you add auto, which I think it's automatic, right? So what is now necessary? What skills?
So, well, Ronald, in general, it is still a little bit necessary to have small expertise in drive tuning, right? Especially because for the drive commissioners, it is a big effort to know all the parameters what you have to set up, right? Today, the TwinCAT Bode plot is helping you. So we have an excitation with different frequencies for the drive, and then we get a feedback with amplitude and phase, and then the expert knows exactly, oh, this curve, I have to tune these parameters, right? And of course, then you need this 150 years experience, right? But now it is really a one-click tuning. So you have the possibility to choose your drive, and then one click, and then we have multiple excitation, so it's very quick to get a response. So it's easy to make this really in a machine for multiple axes.
Okay.
And so that makes life really, really easy, right?
Now, if it's that easy, basically one click, so what is all optimized, Daniel?
As Pascal already mentioned, we do a frequency analysis of the axis, and we are getting out a phase response and a gain response. And with these curves, the software can find out the inertia of the axis, or if it's a linear motor, we find out the mass, the moved mass. This is the first one. Furthermore, we can see in this response, is there a resonance?
Okay.
Can be. If so, then the software is designing a notch filter, for example, to damp this frequency that we avoid the vibration. And the third one, we optimize the velocity controller, the gain. We consider the criterions of stability and get out the best result of the velocity loop as possible with the mechanical system.
So it's basically a complete package and everything is optimized more or less what could happen on the drive.
Yes, yes.
Now, one click, everything optimized, only a little bit experience is needed. Now, how can customers get access to it? They buy a big package now, or what is the next step?
So, Roland, it is very important for us that the auto-tuning is a basic and fundamental part of our motion solution, right?
Yeah.
And so it is integrated in the TwinCAT Drive Manager 2, which is supporting our machine commissioners since several years for the drive tuning in general. There we add now a tab for the auto tuning, and then it is really this one-click stuff what we described, right?
Okay.
And this is free of charge because everyone needs it and makes fully sense for the experts, also as a starting point, right? But also for all the others which have not that deep knowledge.
Okay. But that means then, if this is so easy and free of charge, I need to have very specific drives to use this, or?
Yeah, that's true. We have it for different drives.
Okay, for which ones is it available?
Yeah, we have it also for older drives. So AX5000, you know,
Yes.
it's not the newest product we have. AX8000 and also the AMP8000 is supported in the first step. But also the 48-volt class will follow in the next months. And we try to develop this.
Well, excellent. Auto-tuning will make its way into the TwinCAT world, to the desk of our customers for all drives. Thank you, gentlemen.
You're welcome.
Welcome.
Now, if this is so easy, I think there's not much more to do. And it's easy because we integrate the function based on our knowledge and your requirements into our TwinCAT system. Now, TwinCAT integration is also something we did with our XTS. You might remember our extended transportation system. XTS is around for many years. It's a stable platform for intelligent product transport, and there are always news already in the existing product. And you notice I'm on my way to the XTS department. A lot of people out here today, so that's why it takes a little time, but we're getting closer. And while we get closer, we also get close to my dear colleague, Rob. Now, Rob is here to tell us something about XTS. Good morning, Rob. Good to have you again on the show. I already told on the way out that XTS is proven technology, and at the end it goes about product handling. So how do we handle products traditionally with XTS?
So there's a few different ways that customers have handled the products. They will build either some things like a spring-loaded gripper where they'll drive over a mechanical cam that opens up and can accept a part, or they'll use things like two movers together, and then one mover, by changing the spacing, they can change, open an actuator, or open a gripper, close a gripper, or perform another function.
Okay. And what are the typical applications for that?
So either for part handling, or even in some cases for assembly systems, or they really just want to take the part and perhaps place it on a tray to work with it, and then bring it back and then continue on.
Okay. So now, so far, our product was also transporting just the product. Now there's an update coming up. This is the NCT technology. We talked about this already at the last trade show. NCT means no cable technology. And I think you need to highlight one more time what NCT brings to the mover.
Exactly. So we've had these ways of doing it, but they're all mechanical and they're all not so easy. So now with the NCT, we've got power and we've got data right in the mover.
Yes.
So that gives us, we need the power to drive something. We want to turn an actuator on, we want to move a cylinder, we want to turn a motor. but we need the control, we need the data to tell it when to do this. So now we've got that directly on the mover here, and now we're...
No. If we need data on the mover, we have terminals, but I don't see terminals.
So we've taken the logic of the terminals,
Okay.
and we've put that into the pickup for the NCT part. So pretty much any function that we have in our I/O portfolio, we can mount that into a mover.
Okay, that means this mover here get power and data through this no cable technology right to the mover. Now, what is this application finally all about, Rob?
So this one was for us, we've been trying a few different of the gripper just to give customers an idea what might be possible.
Yeah.
So here we put on a little simple gripper mechanism, and we have a little solenoid that actuates the gripper to move it around. And then we have, more importantly, the feedback to know, did we close on the product, did we not close on the product, right? Did we happen to somehow miss it?
Yeah.
So now we have the feedback to say, okay, is it in the right position, pick up the part, continue on to the next location. And one other important thing is we can actually talk to every mover in the system in parallel every millisecond.
Yeah.
So really, I have complete full control over the system. It's just as if it was wired.
It closes the loop. Thank you, Rob. And we talked about sustainability, about efficiency, about performance, and now also simplicity, because we have the data now available. I think Malte with the camera need to move somehow over to the next motion department, because Felix is right there. So let's continue, Felix.
XTS has 48 volts, and guess what else has 48 volts? Our compact motion technology. So Sven Arne, I need you.
Hey, all right.
A nice wall, some new signs are here. Yes. So what can you tell me? What kind of news do we have in the compact motion world?
Yeah, on the HMI, we have now 2 complete new motion series or motion pro series, and one that we just basically broadened our range of applications that we can use.
So rotary motors in the compact motion series are being fed by an EL7 or an ELM7
most of the time,
are coming to me.
Yes.
But now I see something with four linear movement. So what's that?
Yeah, that's completely new. So basically, we took over the 400-volt counterparts, the AA3000 electric cylinders and the AL8000 linear motors, and basically took them over to now work with the ELM terminals with the 48-volt drives. So the functionality is exactly the same. It's the same plug and go basically with the electric cylinders, and also the linear motors are now specifically made from the winding to work with the ELM terminals.
Okay, so also the translatory motion now possible in the very, very compact form.
Exactly.
If you want to go even more compact, then you can integrate the power electronics in the housing, and I think that's what we did with the new AMI motors, right?
Exactly. That's the kind of second new thing here, apart from the translatory motion. In the rotary field, we now have a new flange size for the AMI. And this gives us just that much more torque that we can close the gap between the AMP series with the flange size 3 and the AMI. So now you don't need, for let's say low force or low torque applications, you don't need to go with 400 volts. You now can use 48 volts and have the same torque at the same level. So again, we're closing the gap in between the application ranges that we can deliver products for.
Okay, it's all about continuity in the motion world. You don't want to buy overhead. You want to buy the product which is exactly perfect for your application. So thank you very much, Sven. I think Roland and Pascal are standing right here.
Yes, we have another.
There are some questions.
Yes, we have another question. We would like
more questions.
Yes, we'd like
to go there.
Yes, it's okay here. Just
we can stay. It's a bit crowded.
Because we got a customer asking for the integration of our auto-tuning into the TwinCAT world, and the key question is this something for TwinCAT build 4026? We talked about this build on Monday already. It will be released in summertime. So I think the question is this combined? So will these both things be mandatorily together?
Luckily, we are independent from the TwinCAT build, so we will support the current build 4024 and also 26. So both will be possible, and if it is available, it is available. And we plan at the moment, after some more tests at real machines, so in real life, of course, we plan at the moment that we are ready in Q3 this year.
Okay, so you can simply wait for the auto-tuning function, then use it in each build you have. Well, thank you, Pascal.
You're welcome.
That's it. Now, what do we do now, Felix?
We start the day and we might do some real work, Roland, maybe. So we have to talk with some people who are running all around the booth. But there is no reason to not tune in tomorrow, because tomorrow at 10 a.m. European time, we will also be live again from the Hanover booth. We will have very nice topics. We will actually have a look at our company numbers together with Friederike. We will talk with Pascal again about weight, not our personal weight, but weighing. So it will be quite interesting.
We have IPCs.
We have IPCs are everywhere.
Yes.
So you need to have them everywhere.
Okay.
And so we look very much forward to welcome you back. If you are in Germany, somewhere in Europe, and you don't know what to do with your Thursday, maybe you come by
Okay.
and have a chat with us.
Have a great day. Thanks for listening. I'll see you tomorrow. Bye-bye, everyone.
Bye-bye and arrivederci.